Okay, welcome to your last lesson for the Pythagorean theorem. A lot of this stuff you know already, but I'm just going to go over a couple more harder examples so you have something to reference later as you're studying, getting ready for your unit test. So, Pythagorean relationship can be used to determine distances that might be difficult or impossible to measure. Right? And this is where you're going to see applications to the Pythagorean theorem in other questions and other areas of your life when you can't just get out your ruler and start measuring a distance. So for example, if we're talking distances like kilometers, right, that are really, really big distances, or maybe distances over water or up trees or in mountains, so things where it's not so easy to get out there and physically measure, Pythagorean theorem works really well. So just as a refresher, right, we've got a diagram here for us, so we'll start with our formula. You're solving for the hypotenuse, right, which is always the c, so that's going to be the unknown, and you don't really care which one's a, which one's b, all ends up being the same. So for this question, you're going to go through and solve for length d, 500 squared, remember you can just go 5 times 5, which is 25, and then add the zeros. Right, and then this one, 144, 12 times 12, add the zeros, right, equals d squared. When you add this all up together, so I type it all into my calculator so I can find the square root of it in a second, ends up being, 1,690,000, right, huge number is d squared. Take the square root of that to find the length of your unknown side. And our final answer is D is 1,300 meters. Remember, that answer makes sense because it's the longest side, the biggest number. Don't forget those units. Okay, so let's dive into a couple questions. Now, we've done ones like the second example here as well. It says the Pythagorean theorem can be used to determine if if the triangle is a right triangle. So I'm going to put a big question mark here, and I believe your sheet has a question mark. We don't know if it's 90 degrees. So to see if it is, and this could be really important if you're building something and you want to make sure it's an exact 90-degree angle, this formula only works for 90-degree angles. So after substituting the numbers in, if I get two sides that are not equal, it's not 90 degrees. So let's see, on the right side, I get 100. On the left side, 6 times 6 is 36. 64 is 8 times 8. Hey, look at this. 100 equals 100. So the answer is yes, right? It is a 90-degree triangle, and that's great, right? You've just kind of proved it to be so. If your answer is no, let's say over here that this was like 94, your answer, you would say nope, right? It's not. And that's okay. No is not a bad answer, right? It's just disproving the fact that, it's proving the fact that you do not have a 90-degree angle. So hopefully those kind of questions are comfortable. And I want to do two definitely more challenging, and then I'm going to leave the ones on the back for you to do as your homework. But let's look at this one here. Now, all words, no picture. You're going to draw your own picture here. Brad places a 10-meter ladder up against a building so that it reaches the second floor window. So I'm just going to draw this, right? Here's a building, right? There's floor 1. Here's floor 2. He's going to get his ladder so it's leaning up against the building like this, right? Hopefully that kind of makes sense to you. Now, the ladder is 10 meters. So I'm going to write 10 meters right here. Now it says the second question, the base of the ladder is 2 meters from the base of the house. So that means that this is 2 meters here. Now I can assume that the house is built at a 90-degree angle. Hopefully those architects had their different levels out and all that sort of stuff, and they noted it's 90. I want to figure out how high the second floor is. Now in this case, how high the second floor is that unknown leg of the triangle. Right? I'm going to call it A in this example. Once you have the picture, everything else should be okay. A squared plus B squared equals C squared. It's in a 90-degree triangle, so we can use this formula. A is the height of the house or the window. I don't know it yet, but I know that I'm 2 meters from the side and that the ladder is 10 meters long. So, right, business as usual, right, subtract 4 from both sides. A squared equals 96. Got to take the square root of both sides just to figure out what the length of A is. And I'll need my calculator for this one. I can estimate, right? I know that the square root of 100 is 10, so this will probably be 9 point something. Let's see, 96? Yep. I'm going to say 9.7979, so let's just say 9.8. And the units we're in are meters. So my concluding sentence is the second floor window is 9.8 meters high. Awesome. Hopefully that's okay. Let's try the last one here. Okay, again, no picture. You're going to have to do your own. We got a cruise ship, right? It travels from Port Stanley north. So just, right, in case you're ever wondering, right, you can always ask which way is north. So I'm going to just draw a little compass rose here. So this is where I'm going to start, right? Here's Port Stanley, and which is close to my hometown. It's going to go north, right? So north is up. And I know that it does that at a speed of 32 kilometers per hour, and that takes 3 hours. Then turns 90 degrees and travels west. So west is this way, right? Now this leg of the trip, ooh, that's a really long one, 29 kilometers per hour for 6.8 hours. When it reaches its final destination at that time, right, so X marks the spot there, how far is the ship from where it started? So this is where we started, this is where we finished. You're going to find the hypotenuse, right? 90-degree angle. I know that we're using the Pythagorean theorem. So, how far? We want to find a distance. Now, what you're given here, though, this is not a distance. This is not a distance. You need to find those two distances before you can use the formula a squared plus b squared equals c squared. Tough question, eh? So let's find the difference, or the distance. Now, if I can go 32 kilometers in 1 hour, 32 kilometers per hour, and I do that for 3 hours, I'm going to multiply that by 3, right? So what happens here is that that first section is 96 kilometers, right? Hopefully that makes sense. So I'm going to write 96 kilometers here. Okay, and I'm going to do some more work on the side here. So 29 kilometers per hour. So that's how far I go in 1 hour. I'm going to do that for 6.8 hours. So let me grab my calculator to help me with this one. I've got, there we go, calculator. 29 times 6.8. That is 197.2 kilometers. All right, so I'm going to write that over here in black too. 197.2 kilometers. Okay, I'm on my mission. I'm going to find hypotenuse C. So I'm going to put in 197.2 squared plus, right, there it is, 96 squared plus B squared. I put those brackets in, but you don't really need them. Whatever. So 197.2 squared, that's a calculator question for me. Woo, big number. 38,887.84. And I'm going to add to that what 94 squared is, 830,584. That equals c squared. So let me do a little work on my calculator here. 87.84. Those back together. 471.84 equals c squared. Take the square root of both sides. And the ship is precisely, or I shouldn't say precisely, approximately 932.5 kilometers from where it started after that long trip. So this question, right, you're not looking at the total distance it traveled, just I want to know how far it is from where it started. Great. So then, concluding second sentence, the ship is 932.5 kilometers away. Great. So hopefully that makes sense. If you have any questions, please be sure to ask in class. You've got 1, 2, 3 questions on the back. Check the answer key posted with the next day's lesson, and we'll see you at school.